We have discussed quite a lot in STA, so I thought let me just quickly revise and then proceed further. Right, so we started with STA, STA access. So we discussed about the various challenges in the current enterprise networks, and then we discussed on how STA kind of fits in, right? Where mainly with respect to the identity-based segmentation, the automation which comes in, the security policies, and all of that. So we discussed why do we even need ST access, right? So that was this piece. The second piece was we discussed the various components, right? When I say components in the ST access fabric, right, we have your edge routers, we have your the control nodes, right? We have the border nodes, fusion routers, and we also talked about how ICE and the WLC plays a part as well. So that was the main part of the components, right? Then we talked about the key concepts, right, or more like the terminologies which we are going to use in ST access, like the VNs, right, the virtual networks. I think we talked about the Anycast gateways, right? We talked about SGTs, TrustSec, right? All of that happened in my key concepts. Going ahead, we talked about fabric, right? Fabric is very important, and don't get confused with underlay and overlay here. Underlay is something which is always there in your network, and it has nothing to do with your ST access. It's still going to be there, it's still going to be used, but fabric is basically your overlay, right? So this is the overlay that's basically ST access. In simple terms, if you ask me, ST access is nothing but the overlay, right? So we talked about how this overlay is going to have a control plane, which is your Lisp, your data plane, which is your VXLAN, and the policy plane, which is your SGT, right? So we did so much. Now going ahead, what we're going to do is we are going to look into how the wired and the wireless networks are integrated into the ST access framework, and we'll also finally end with a packet trace in the whole network, right? Great. So I've picked up few of these slides or the diagrams from a Cisco live presentation to explain some of the interesting pieces, right? To start with, the first thing is my DHCP. You know that in any network we need a DHCP, right? That's the first action or the first step which happens when you bring in a device into your network, right? Great. So we have talked about that. So now let's assume that this is the ST access network. You have a very basic ST access, right? You have like 3 edge nodes, a control node, a border, couple of border nodes, right? You have the fusion router, and you have the shared services where you have the DHCP server right over here. So we have a client who comes in, right? As soon as he comes in, what happens? He's going to be authenticated, right, with the ICE, right, which I'm pretty sure it's not shown here, but it's there. The ICE is there, the DNAC center is there, the WLC is there. Just assume it is there. But once it gets authenticated, it's going to be assigned a particular pool, right? So in this case, the IP address pool is 10.1.18.0, right? Now that's not enough. I need a IP address client, right? For doing I need a IP address, right, assigned to this client to proceed with any of the network related activities. So how do I get a IP address? Yes, DHCP request, right? So the client over here starts by sending a DHCP request. Great. Now we have already talked about the Anycast gateway, right? So that is what is going to come into play here. We have learned that we are going to have the same Anycast gateway, right, like the one which is here, 10.1.18.1. From this pool, there is going to be a Anycast gateway which is going to be the same on all my edge routers, 10.1.18.1, right? So we're going to have this gateway configured on my edge, right? It's a switch, so it's going to be configured as a SVI, right? The same SVI is going to be present on edge 1, edge 2, edge 3, right? Great. So that SVI will pick up this request, and we'll also have something like a DHCP helper address configured for that SVI, right? Again, when I say configured, we don't have to really do any of the configuration, right? So from the DNAC center, right, all of this is automated, right? The whole network fabric, the configurations related to network fabric is automated. So when you discover your network, right, all of these configurations can be pushed down, and like you can automate all of this. You don't have to do anything, right? So I'm just telling it out so that you can understand how it actually works, right? So yeah, so we have a SVI, we have a DHCP helper address configured over here, and as a result of that, the DHCP request gets picked and it is then sent to the border router over here, right? So once the DHCP request comes here, so let me ask a question now. right? Let's assume that the DHCP request came here, and using the Fusion router, it went to the DHCP server. Now that there is a reply which comes back, right? From the DHCP server, you need a reply, right? Where there's a lot of handshake which happens, but let's just tone it down, and let's assume that there's a reply, there's a DHCP reply which comes. But the question here is, since all my edge routers have the same SVI configured on them, right? Even this guy has it, switch 2 or the edge 2 has it, edge 3 has it, right? How does this border know the exact location, right, where you have to send this particular DHCP reply? Because all the three guys have the same IP address, same SVI, right? That was my question as well when I was reading this. But this is really good. What they're doing here is, when you're sending this DHCP unicast request to the border, we send it using something called as option 82, right? Option 82. So it's you would have heard about option 43 in DHCP and so on, right? So this is similarly option 82. So as part of this option 82, what do? You send certain information, right? So you can see here the option 82 tells me that you're going to send the RLOC address. RLOC address, for time being, just assume it is the loopback address, right? So when this edge over here, this edge which is present here, when this edge is sending the request, it's going to send its RLOC, which is 1.1.1, and the VN ID, because this client is at the end of the day connected, coming in via a VRF or a VN, right? So that VN ID, so 1.1.1 and 10 is going to be sent, right? And the border router will send that option 82 as is, and my DHCP server will reflect back, right, the same option 82, right? So again, like I said, all of this if I have to do this manually, I'll have to sit and do hours of configurations, right? But because we are talking about DNA, we are talking about SD access, all of these configurations which I'm trying to literally tell out loud is basically automatically configured in your fabric, right? So the DHCP reply comes to the border. Now the DHCP reply needs to be punted to the CPU, so that you over here, right, the DHCP reply has come here, right? Let me use a different color. So the DHCP reply has come here from where? From my DHCP server. Now that DHCP reply will go down to the CPU, and we are going to extract what? We are going to extract your RLOC information, right? RLOC information and your VNI information, or the VNID, right? Because I said because of option 82, that information was sent over here, and the DHCP server just reflected that information, right? So now the border node correctly knows, right, for which edge node this particular DHCP reply has to be destined, right? So that's how it is working out, right? So that's a very interesting way. Else it would have been a very big problem, because if the border node is sitting here, with respect to the border node, all the three edge devices seem to have the same SVI. So he would have been confused as to, okay, where should I send? But because of the whole option 82, what's happening is, the border node clearly understands to which edge node, he will have to send this DHCP reply, right? Once he realizes that, he's going to send a DHCP, reply back to edge node, 1 over here, or 2, whichever is this one. And from there, the edge node will then, provide that IP address to the client. Right? Hope that's clear. So that is how the DHCP works in my fabric. Great. So once the DHCP is done, what do we do next? So let's talk about what happens when a wired host, right, joins the fabric. Right? So we have a wired host here, and we want to basically go and join the fabric. Wired, right? So we have a wired host here. You can see the green one over here, right? This guy. So when the wired host comes into the network, connects to the fabric, it obviously connects to the edge device, right? So when it joins the fabric, the first thing it does is, obviously it gets authenticated, it gets an IP address using the DHCP process which we saw earlier. Then the edge, which is here, this guy, will send a map register to the control plane node. Here you can see the control plane node is over here. So this guy will send a map register, right? He's gonna say, please register me, and the edge node will send the IP address and the MAC address, right, from here. So that's what you can see here. So you see the IP address, which is 1.1.1, right? And the MAC address is AA and so on, right? So this information is sent by the edge node to the control plane node. So and that gets populated on the control planes, um, the control planes table, right? You have this table, the three tables over here, and this is basically the Lisp operation which is happening, right? Where the Lisp protocol or the control plane protocol of the fabric. This is really what goes under the hood, right? When we talk about the control plane. So you register the IP, you register the MAC, and then the control plane automatically figures out the address, resolution table, or basically maps the IP address from here and the MAC address and puts it in this table, right? As simple as that. So once that is there, now when a new client comes in, and let's say this guy who is here wants to talk to this guy, right? The only job he has to do is he just has to kind of like go and query this control plane node, and this guy has all the information, right? So he's going to reply back with the information, and then the control plane node, which is the edge device which is here, will create the VXLAN tunnel, right? So we talked about how the VXLAN is playing the data plane path, right? So once you have the information, this is going to create the VXLAN tunnel between these both guys, and there you go, the information transfer happens, right? That's in the data plane, right? But that's how the whole process which goes under when we talk about wired networks, right? So yeah, so that's the wired part. Now what? Let's now talk a little bit on the access point side, right, or the wireless side, right? So in wireless, it's not very straightforward when I say because there are two variables here. You have an access point and then you have a wireless host as well, right? So how does it all work out in a access point? So the first step is the access point has to register to the fabric. The second point is the wireless client has to register, right? These both guys. So access point, what happens to the access point? First step, yes, the access point goes and forget the red line over here for a minute now, right? Just assume that you have an access point. I mean, this is a complete picture, so this is the final step which I will explain how it is coming, but let's just assume that you have the access point here, right? The access point just came to the fabric, joins the fabric to the edge node. After the access point gets an IP address, the same process, right? Access point is authenticated, it gets an IP address and all of that. The edge node which is here does the same step which it did earlier. It's going to register. It is going to register the IP address and the MAC address of the AP with the control plane node. That's how you have this information, right? The 2.2.2 and the BB whatever, that's the MAC address. So that's got registered. And then obviously the same step happens again. The address resolution table, which is basically populated by using this two information, right? But this is where the distinction happens. So this is till here whatever we talked was the same as the wired host as well, right? Now for a minute, I don't want to confuse you guys. We are talking about this one, right? The AP. How does AP register, right? And we have realized the AP has finally registered to the control plane node, and we have this information. But this is not the end. When we talk about an AP, there are a couple of other steps which happen, right? So what are those steps? So in parallel, right, while this process is happening, while this all control plane node registering is happening, the AP, after getting the IP address, will also try to register itself with a WLC, right? You know that there is a WLC over here, right? So this AP will try to register to the WLC as well, because APs always have their loyalty towards the WLC, right? Every single AP in your network is registered to the WLC, right? So this will be happening in parallel, right? So the WLC after or upon receiving the request, right, will query whom? So this WLC will also query this guy, will also query the control plane to find the location of the AP using the mapping which we have here, right? So the WLC will tell that, okay, I have received a request for 2.2.2, right? Please, can you tell me behind which node is this particular AP coming into my network, right? So that information is there on my control plane node, right? So the control plane node replies back saying that, hey WLC, yes, we we have a AP in the network, and he is registered behind the edge node 1, right? This is the edge node 1. So that information is given back to whom? It's given back to my WLC. Now the WLC, so this is why I keep on telling that it's a fabric WLC, right? It is part of the fabric. So you see, this WLC now will also maintain another table, right? And that table, in simple terms, I can say it is basically AP to RLock table, right? So he's going to maintain information that AP1 is now seated behind the edge 1, or actually the RLock address will be there, which will be, let's say, 1.1.1, right? So this information is actually kind of like stored on the WLC. So that is that is like the extra step, right? Why are we doing this? Because now WLC, because any information, if you have to push down to the AP, it has to happen through WLC, right? Because WLC is kind of like the central controller for all the APs. And like I said earlier, we are still using my WLCs because provisioning of APs and all of that becomes very easier, right? Why did we even do this extra step? Because the WLC, which is now, we are still not done, right? There is one last step. So WLC will now inform my AP. What will it inform, right? So it is going to inform back. It's going to inform the AP that its default gateway is the edge node 1. This is the one, right? So it's going to go back to AP and tell him that, see, your default gateway is the edge node 1, and please create a VXLAN tunnel, right, from yourself to the edge node 1, right? So that is where this red tunnel comes into picture, right? This is very, very important, which you shouldn't miss. So what we have done, we have got the AP into the fabric, we have got the edge node going and registering to the control plane node, which we did here. Then the AP also in parallel was talking to my WLC, trying to register itself with the WLC. The WLC then queried my control plane table to get the location of this AP. Once it went and updated its own AP to RLock table. Why did we do that? Because now it can send back the information to the AP telling that, hey AP, your default gateway is edge 1, right? So that this AP can now kind of like create the VXLAN tunnel between itself and the edge 1, right? Now this goes back to a very interesting statement, right, which probably you have heard. In SD access, we have kind of like a convergence between what? The wired and the wireless, right? Wired and the wireless as well. So we have convergence. Why do I say it's convergence? Because now you kind of like have, okay, my pen is acting out, give me a second. Okay, so now you kind of have the wired clients and the wireless clients, right, here, right over here, and they are coming into my switch. All the information will go through my switch, because in case of a wireless network, wireless client, I've just now created a VXLAN tunnel. In case of my wired client, I don't even have that VXLAN tunnel, right? It is directly connected to the switch, so I'm not worried. But in case of my wireless client, I've just established this tunnel, so all the information, all the data will now flow through my switch, right? So it's unified. It's no more that, okay, the wireless client data is going to WLC and this is going to switch. No, it's all happening here. It's all happening on the switch. Now, how is this useful? This is really, really good, because now I can do all my policing, right? That's what we have been talking about in SD access. One of the important thing is the policy plane, the trust sec, this SGT, scalable groups, right? So I can do amazing things. I can do like a QoS, right, for both my wired and wireless traffic. Earlier, if you had to do a QoS, probably you had to do that on the WLC, right? But now you can do all the QoS at a centralized place, right, on the DNAC center, and then push those policies down, and they will get acted on the switch. And like I said, both my wired and wireless traffic is going through the switch. So there you go. So it's all unified. It's convergence, right? So yeah, so that's really interesting. We're using the VXLAN, right, as the data plane for both my wired and wireless traffic, right? And that's how we are achieving the convergence part. Great. About what happens when a wireless client joins the fabric, right? We earlier talked about what happens when an access point joins. But just having access point is not enough. Now we want the wireless client, right? What we have mentioned here. Just take this, right? So this is the client, right? When this client, wireless client, is connecting to the AP, what happens, right? So as soon as the host joins, obviously he's going to get an IP address, he gets authenticated, he gets an IP address, all of that. The edge which is here will send the map register to whom? To the control node, right? It's going to send the map register, populates the database. Populates the database, when I say, it means populating the IP address and the MAC address table, right? Simultaneously, because it is a wireless client, right? So this AP will simultaneously also register the MAC address of the host to whom? To the WLC over here, right? And for the authentication purposes, right? Now the WLC, once it receives the MAC address of the host from where? From the AP, it will try to look into the AP to RLOC table, which we earlier, described, right? So we have a AP to RLOC table here on the WLC. So this is my WLC. So WLC has received a MAC address of the host, right, from the AP, and it will now try to look into the AP to RLOC table to find out where the AP is located, right, to understand where this AP is located, because in a huge network you're going to have many APs, right? So it's going to try to find where this AP is located. The WLC, once it resolves the location from this table, you get to know where the AP is located. Let's say it's located at 1.1.1, right? The WLC, once it resolves the location of the client, right, it registers that information with the control. So from a WLC's perspective, we have what information? We have the RLOC information, we have the MAC address of the client also, right, which was sent by my AP. So I have actually all the information which I don't have the IP address, right, because WLC understands only the MAC address. So this is the MAC's client, client's MAC, right? So WLC has the client's MAC. WLC also knows that this client is behind what? Behind 1.1.1, behind this edge, right? That information is there. So it will register that information with the control plane node, right? So remember, my edge node has already tried to, or already populated the control plane node with the information. The WLC also will try to do it, right? Because he also has the information, right? But always remember, it is going to populate only this table, this part of the table, MAC to RLOC, because it obviously can't do this because it doesn't have the IP address. WLC never understands the IP address, right? Now the interesting piece is the edge node has populated this entry, and the WLC also is going to populate something here. Now if these both don't match, right, sometimes there is a possibility that these two don't match, because let's say when after the edge registered, maybe this client moved to a different segment, moved to a different edge, maybe it came down over here, right? So there could be a stale entry. So if the two entries don't match, which are the two entries? The one which is done by the edge node and the one which I am going to populate it using my WLC, right? So if these both entries don't match, then that that host is completely removed from the table, right? And if it does match, then yes, it is going to retain it, and it is going to update the address resolution table, right? So that's something which happens when a wireless client is joining. Just to recap, so we have the wireless client joining, it will authenticate, it will get the IP address from the DHCP, all of that. After that, the edge tries to register, or actually registers this client onto the control plane node. Simultaneously, our AP is also proactively trying to send the MAC address of this particular client to whom? To the WLC. The WLC will consult its own AP to RLOC table to figure out where this particular client is coming from, behind which AP, right? Once that is resolved, the WLC then goes and tries to update the control plane table, which has already been updated by my edge node, right? It will try to re-update it. So when you're trying to do that, if the MAC to RLOC data which is already populated by my edge node, if it doesn't matches to what as a WLC is going to update, then it means that this entry which is there in the table is stale, right? So that entry is completely removed. Now if the information is same, then we will keep the information which is already there, then we will try to update the address resolution table, because I already have the IP address, I have the MAC address, right? So that's pretty simple. So that's how the wireless, registration happens. Talk about mobility, right? We have been talking about how ST access makes it very flexible for seamless video and voice calls and all of that, right? So how does it actually play out is what we are going to look. So mobility, when we talk about mobility, let's assume that for a minute that we have this host, right? Let me just get this cancelled out. I'm just talking about the same host. Yeah, so we have this host who is here. Let's say he's on the move. He's on the move from where? From, let's say, this building to a different building, right? He's on the move and he's moving from AP1 to AP2. So there are two APs here. Let's say he's moving from AP1 to AP2. So when the move is happening, the AP detects it first and registers the MAC address of the client, to the WLC as a mobility event. So we have seen in the previous section how whenever a endpoint or edge, whenever an edge node is registering anything to the control plane, right? There is a activity which happens in parallel, right? So in this case, the AP2 is kind of going and registering, right, the MAC address to the WLC, right? Registers the MAC address of the client to the WLC as a mobility event, right? So AP is the first guy to detect this change. So the WLC previously had this particular host, right, who has actually moved, had this host registered under AP1, but now it sees that, oh, I've got a mobility event, I've got a notification that this host has moved to AP2. So what does WLC do? It will consult its table. It just has one table, right? What is the table? It's called AP2 RLOG table, right? It has two entries over here. One is the AP1 and the other one is AP2, right? So you have this table. So it will consult this RLOG table to understand where is this AP2 actually sitting, right? Is it sitting behind is it sitting behind, you need to know the location, right? So is it behind your edge 1 or is it behind edge 2? So it is trying to figure out that, right? So once it gets that information, the WLC will now register this new location of the host with the control plane. So we have seen that how WLC also plays a part in updating the control plane node. It's not just the edge nodes, but WLC also does it in case of wireless clients. So the WLC will now tell the control plane that, hey, I've got a notification from my AP that the host has moved, right? So, but when you look at the control plane information, it will still have the stale information, right? It will have the outdated information, because here the WLC will be telling that the node the client has actually moved behind, let's say this is edge 3 and this is edge 1, right? So the control plane will still have the old information. It will have the information which says the client is behind edge 1, but as a WLC it's going and updating the control plane node, telling that I have the latest information. So the control plane basically accepts the WLC or prefers the WLC's information, right? And it will correct the control plane node, right? So that's how this correction is seen here. So it is updating, it is telling that BB, this particular MAC address is now behind edge node 3, right? And it's not just it has to update this table, it also has to update this table. So once this is happening, you can see a blue mark or a blue arrow going in. So first this table gets updated, the MAC to RLOG, and after that this will go and update the IP to RLOG table as well, right? It will tell that, hey, please update your table because the wireless client has actually moved from edge 1 to edge 3, so this gets updated, right? And obviously after that, once that is done, it is very easy to update the address resolution table, right? So that's how the mobility works. The important point to note here is that the AP is the first one to recognize this event, right? Whenever a client is moving, it goes and updates the WLC. The WLC now checks the AP to RLOG table to understand where is this new AP situated. Once it understands that yes, it is behind edge 3, right, it will take that information and now try to update the control plane table which is on the control plane node, right? It will try to update that, but it will also see that there is a stale entry, right? So it will update that entry first, because WLC always has the latest information, right, with respect to wireless clients. So it will update that, and from there, the IP to unlock table also will be updated, because now we know that now we know for sure that the client has actually moved behind edge 3 and it is no longer behind edge 1. Once that is done, the address resolution table is filled and updated as well. So that's how the mobility works. So that's how the whole funda around how a person who is, it will be a very good exercise you can do, wherein you're on a WebEx call, right, or on a voice call, and you move from say AP1 to AP2, and you can see all of these tables updating this way, right? So that was relating to the mobility part. This is going to be the last part of this lecture, where we are going to now look at the packet trace, right? How the communication actually happens between two clients, right? To start with, the first example which I want to take here is that where both my clients are in the same subnet, right? What I mean by that is you can see my host 1 over here, right? I have my host 1, I have my host 2, right? And both of them are in the same subnet, which is 1. Use a different one, right? It's 1.1.1 over here, and this guy is 1.1.1.2, right? Great. So let's assume that. Now, so let's assume the communication is happening, or host 2 wants to talk to host 1, right? So since they're in the same subnet, what is the first rule? If you're in the same subnet, you want to talk to someone, you have to do a ARP request, right? You have to do a ARP request for the MAC address of what? Host 1, right? So you have to do a ARP request, right? So you have a packet, the ARP packet coming with the source address, IP address being host 2, the destination IP address is host 1, the source MAC is H2 obviously because over here, and the destination MAC being all F's, right? That's how the ARP request goes. So the ARP request is coming in from here to my edge node. The edge node will intercept the ARP request from the host 2 to host 1, and then will in turn contact the control plane, right, to ask the MAC address of host 1. So it will, it has looked at the ARP request and it will ask my control plane node, hey, can you give me the MAC address of host 1? So the control plane node will consult its table. So it has this amazing table, right? The table with all the mappings. So it will consult this and it will look at this entry specifically, right? It looks at this and it says, yes, I have the MAC address of my host 1, right? How is this table built? We have talked about this earlier. Whenever a client came in, all of this table was getting built. We looked at this table for both my wired and wireless clients, right? So the control plane node looks at this table and tells that, yes, I have the MAC entry, and it's going to reply back to whom? To my edge node here, telling that, yes, this is the MAC address you are looking for, right? Once the edge node gets the MAC address for the host 1, it will again consult the control plane node as to where this host 1 is located, right? Because now you need to, for the VXLAN to work, you need to know the edge node, right? So this guy has just replied back with the resolution. So this guy is again going to ask him one more question. So he's going to say, okay, thanks for the MAC. Now tell me where is, so this is going to, let me use a different color. So there is another request which goes like this, and he's going to say, tell me the location, right? So now the control plane node will reply back with this information, right? This is the information which he's looking for. So he's going to say, hey, the MAC address, right, of the client which I gave you earlier is actually seated behind edge 1, right? So it uses the table and gives that information. Now the job is still not done, right? Now what if the yeah, so the fabric edge node, right, upon receiving this new information, receiving the map reply information, will install this entry in its own forwarding table, because again, like, it can use this information for its future data transfer, right? It doesn't have to always ask the control plane. So it keeps a cache, so that it can take this information and keep it in a small table over here, right? Store it here, so that in future I don't have to always repeatedly ask the control plane node, right? So once you have the information here, then it is all like how a switch would behave, right? The edge node will now convert the ARP. So there is one interesting piece which happens here. So now what has happened is my edge node has received the information about the MAC address. It has also received the information about the location, right, of this particular host with whom he wants to communicate, right? So now what he'll do is he'll send one unicast kind of an ARP. Have you ever heard of a unicast ARP? Till now we have always done ARP, and ARP was always a broadcast, right? But now it's going to do a unicast ARP because he already knows the MAC address, right? So it's going to do a unicast ARP to this guy, right? Asking him, it's a ARP, it's a normal ARP, but only the difference is instead of having the destination MAC as odd Fs, it's going to just do a unicast ARP. It's kind of like to reconfirm, right? Though it has already have the MAC address, it's still trying to reconfirm. So the edge node 1, upon receiving this ARP request, will forward it to the destination host, right? And it will also install this entry in its own layer to forwarding table, again similar to like source based learning which we do in any switch, right? Now the final part, obviously this host will unicast ARP reply to the host 2, right? And once everything is done, once my amazing the edge node over here has confirmed everything, what is going to do is that it will create that VXLAN tunnel between this edge and this edge, and it is going to transfer the data and make sure that the host 2 is able to communicate to host 1, right? So when I say VXLAN, it's at the end of the day nothing but you'll have an inner packet and you'll have the VXLAN outside, right? VXLAN header, we talked about this earlier. So you'll have the payload and all of that happening here, right? But the VXLAN header is going to have like another IP address, the source IP and destination IP. The source IP will be that of the edge 1, whatever this edge is, edge 3, and the destination IP in the outside header will be that of this one, right? So it's going to form, it's more like as simple as a tunnel. How tunnels work, right? Let's assume for a minute that it will work just like a GRE tunnel, right? So that's the whole functioning, right, which happens. And mind you, this is for the same when both my hosts are in the same subnet, right? 1.1.1 and 1.1.2, right? Just to recap, so you had the ARP request going into edge. The edge first asked the information from the control plane node about the MAC information, and he also got the reply. The MAC information was given to my edge. My edge is going to ask a second question asking about where is this edge located, or where is this host located, to be more specific, behind which RLock or behind which edge node is it located. So my control plane node will look at the table again and give the second piece of information. Now once you have that, it is not going to just take it at face value. It wants to reconfirm. So it's going to send a unicast ARP. We have never heard about unicast ARP, but before this we have always done broadcast ARP, but here it's going to do a unicast ARP just to reconfirm, right? Once it gets the ARP reply, now it will form its actual data packet using this amazing VXLAN technology, right? Just put a header outside and send the data to the other side, and once it goes there, inside VXLAN we have read about how VXLAN header also encompasses the VNID, the SGT, all of this information is inside this, right? So that's how this switch will decide if this host has to communicate with host 1, all the policies come into picture, the VN information comes into picture, and then the actual data communication is going to happen, right? So that's about communication within the same subnet. Now I also want to talk about how the communication would happen if it is between two different subnets, right? So here it's going to be like 1.1.1.1, and here the IP address is 2.2.2. So they are in two different subnets. Now since they are in two different subnets, there is no requirement of any ARP, right? There is no ARP. What is going to happen is that from here, let's say we are doing a ping, right? So the ping request will have a source IP of this host 2, destination IP of host 1. The source MAC is H2 MAC, the host 2 MAC, and the destination MAC is going to be the gateway, right? The SVI which is here, the gateway of my edge node. The edge 3 will intercept the request from host 2, and it will obviously go to my control plane node to ask the information, ask the information about what? So it's going to ask the information, hey, can you give me the information about this host 1, right? This host 1 is here, so it's going to ask, I want the information about host 1, can you give me the information as to where this host 1 is located? So my control plane will now just give this information. If you look at above, we were using both of these information, but now we are just going to use this information, right, which is my location. So it's going to reply back saying, yes, I have this host and it is connected behind edge 1. Now right, so the fabric edge node, upon receiving this map reply, will install this entry, in its own layer 3 forwarding table, right, because it's layer 3, it's different subnet, right, it's routing now. So it will install this into its own layer 3 table, a small table here, so that like I said earlier, it's like a cache. So it's like any other routing table, right? It's going to keep this information here, because once he got the map reply like this, it's going to take this information and store it here. Now the edge node will now send the ping request received from host 2, right, to now edge node 1 using the overlay encapsulating your VXLAN, right? As simple as that. So once he has all the information to form the packet, he's going to create, let me use a different color, he's going to create this tunnel from your edge node 1 to edge node 2, and using that tunnel it's going to transfer all the information. And the same thing applies now as well. So I have my payload here like this, and I have my VXLAN header, right? And the amazing thing is we have also retained the Ethernet information here, right? We have not removed it. That's the main difference which I was talking earlier. In case of my VXLAN, we retain the Ethernet information. So my VXLAN would give me my SGT and my VN information, and my Ethernet would help me understand the MAC address at the layer 2. So once the packet goes to this edge, right, the decapsulation happens, right? The decapsulation happens, and this information is parsed, and using this Ethernet we are going to kind of like send the data to the right host, because this is a switch, it can have hundreds of hosts, we have to send the information to the right host. So that happens using the Ethernet, right? So yeah, I think that's the whole packet flow part which I wanted to cover here. Just to recap, whatever did we do, we started with why do we use ST-access, right? Then we talked about the various components, right? In the why part we also talked about the various network challenges, how ST-access is helping the identity-based segmentation, the automation which is coming in the network fabric, all of that. We talked about the components, for example, the edge node, the the control plane nodes, fusion routers, the border nodes. We talked about ICE, we talked about WLC. In the key concepts, we talked about mainly the virtual networks, SGT, and I think the Anycast gateway and all of that. In the fabric, we talked about how the underlay is differs from the overlay, and fabric is basically the overlay. The whole ST-access solution itself is the overlay solution, right? And in the overlay, we talked about how the control plane uses Lisp, data plane uses VXLAN, and the policy plane is using your SGTs, right? And then we did a very interesting exercise as to how a wired node would join the fabric, how a access point will join that fabric, and how a wireless client would join the fabric, right? And finally we concluded with a packet trace, right? In the packet trace we looked into two important things. We looked in the same subnet, and we also looked it in the different subnet, right? How if both your hosts are in same subnet, how would that play out? And we also looked into how it would work if the hosts are in a different subnet. All right, thanks for watching. This was a very raw kind of a lecture or a video which I kind of put up. Probably I'll probably create few labs around this, and to kind of demonstrate the technology at play in future. But thanks for watching, and have a good day.